Okay, so today we got the hard problem. Number of digit 1 given integer n, count the total number of digit 1 appearing in all non-negative integers less than or equal to n. What the bruh. Now let's ask, what a stupid problem, another one of these. Well, okay, so first so it's one time, right? And then we go for num in range 10,000. Okay, so I mean, my intuition would be to first check numbers like for x in, or like nums is 10, 100, 1000, 10,000, 100,000, for I in range 0 when nums minus 1, so 0 can be excluded. And then we go for num in range nums I plus 1. Full count is that, and then full count plus equals string num count 1, and then cent append full count plus cent minus 1, and then print count, and then return 0. So 20, really? So in 10, that's interesting. Okay, I mean, easy, we got the pattern, right? And then, so for 13 we would just find 1, right? And then we would have to investigate 13. And we do that in this way. So we can't set to 0, but if there would be like 23, right? We would count so like I can store like I times 10 to 10 to, so I plus 1 for I in range, I think 10. Let's see. So this is smaller than 10, small 100, 10 to 3, 10 to 4, 10 to 5, 10 to 6, 10 to 7, 10 to 10, small to 10 to 9, and small to 10 to 10. Probably don't need the last one, but whatever. Okay. So let's say we have like a number 56, right? And we can have 13 too, but who cares? So for 56, right? That's string n is string n, right? And then we find L is like length, and then we want that minus 2, right? So that's ans nums L, right? So that's like okay, and now we wanna count we look at the first digit, right? And then first ans is nums L, of course, because we set digit to 0 and whatever. Then is it really 20 though? Like 1, then it's in 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and then it's 21, 31, 41, 51, 61, 71, 81, 91. It's 20, okay. So that's the answer. And now here is what we are doing. For the in range length, so we go through each digit, or yeah. And now if sn digit is 1, plus sn count 1, and then, well, if the first digit is 5, that's n, so that's 0, 1, I think plus 1, or no, yeah, this, and then reverse if that works. Not sure if that exists in Python. Runtime error. Okay, that exists. So if the first digit is 1, so let's have like a current contribution, which is equal to digit is equal to int snd. So current contribution is digit minus 1 times what? Nums b plus 1. Yeah, I would do like nums append 0 this way. So smaller numbers than 1, I guess with 1 is 0. So that's the current contribution. And then, okay, so I'm back in here discussing problems. I hate these digit counting problems, every time a pain. So if the first digit is not 1, then we also have to count the ones contribution, and 1 is there. So we have to count one's contribution. So how many times does 1 occur? So we power, and then that's n minus 1, and then it occurs current contri plus equals 10 to the power of power. Actually not n minus 1, but n minus d minus 1. Okay, so 10 times power. Yeah. Wait. No. Like this, because no, like this. So minus 1, and then that's it. No, 16 here, 0, 21. How you count 21, my brother? Okay. Maybe like this. No, that's too much. So because first we count one contribution, right? And then we go into double digits. And our current contribution is suddenly 9. Which I don't think makes sense, because like n is 2, so 10, it's 19. Okay, and y is expected 16 in this case. I mean, here it should be 6. So first of all, y, okay, 2 I can understand. So we got 1 and then 1 in 13, and then we count numbers 10, 11, 12, which has 1, 2, 3, 4. What? What the hell? Okay, so that was the broken thing. So let's figure out why it's 2 here. So nothing, and that's not 1. Wait, but no, it should be 1 for no. $12. Not great. No, that's fair, but for here, so what for 1? That is if else current contribution is what? Like count digit 1 otherwise we return ans plus current contribution plus self digit count of sn, so int sn1 still 2. That is weird. If n is 1, then we return 3. So how many digits was there, and then plus int sn1. Okay, so we got the last case, and now just figure out why this is wrong. I mean, for 56 it should be way more than 14, or no, or should it really be 15? So we are at the 0th digit. if d is equal to length, that's like n minus 1 okay, so something, we have something. I mean, this is absolute dog water shit. For 11 we output too much. Okay, that sucks. So only thing that is left to count is number 10. That's weird. So digit is 1. Digit is 1. What? Well, okay, I didn't think of edge case of 0. So if digits is over 1, well, if it's 0, then we just don't count. If digit from D, of course. How does it even work, brother? think this is starting to really get ridiculous. Okay, so here is what I'm doing. I am making a function smaller, right? Let's call it like x. Nah, beware of overflow. Wow, what a fucking hint. Like, okay, let's say we consider from first digit. And now, okay, so first digit, if it's 5, so right, so ns star n, nlen ns, then here is what we consider. So if the first digit is not 1, yeah, I think this should be easier than what I did. So if it's not 1, right, here is what we are doing. So for each of them, so we got digit ns0, digit ns0, int ns0, if digit don't equal 1, then we return self count digit 1 from int ns1, right, so that's the end, times digit minus 1, no, plus digit minus 1 times, and that's like nums for 304,000. Okay, I think that's fair. So this So else if we have 1, or if we have, okay, so if we have 1, then what happens? Then we want number of smaller numbers. So smaller is int ns0, no, ns19, yeah. So how many are smaller? That's contributions of ones plus self count digit 1. So actually we need this in both. So that's subans, this. Always missing 2, that's weird. Let's do 56 if it works. No. What? Are you kidding? No, that's not true. So smaller than or equal to digit 1, one number only, one number, right? So the answer of that should be 1. First digit, if digit is 1, no it's not. Okay, so then we got sub answer plus shouldn't it be like 2 times this? And still this is wrong. So digits actually let's do it like that. So if it's 2 digits, still nothing. Okay, so from 0 to 10 we got one number, then we got one number for 50 to 56, then we got for 10, 20, 30, 40 we also got one number, so we are at 6 numbers. And then finally there should be so that should be like 10 to the power of n minus 1. Okay, so this one worked. What about 10? that's like okay. So here we have one answer, because if it's one, then we need what? Nums and minus 2. So that's one number for smaller ones. Then one number here. And then for the number of numbers here. Like that. Ain't no way I got it. Pretty simple. Pretty simple, my brother. Okay, so simple recursion. If the number if n has only one digit, we return the answer is trivial. Otherwise, if we have two cases. First digit is over 1. And first digit is equal to 1. In the first case, in the first case, 2351. Oh my days, I'm not gonna do anything again. Whatever. Okay, so in the first case, few distinct cases. Let n have the digits. Then the n digits, and the first one is b. For numbers starting with 0 through d minus 1, for numbers starting with n digit numbers starting with 0 for minus 1, consider 0 a for n digit numbers starting with 1 for n minus 1, for n digit numbers starting with n minus 1 numbers we have to count the number of ones occurring in them, which is digit times, and now that's what n is the power, then that's n minus 1 times 10 to n minus 2 digit c dot n minus 1 c dot 10 to n minus 2. Okay. You can figure the n minus 1 c dot 10 n minus 2 part by just counting numbers, number of ones in numbers smaller than 10 to I. For small I. Replace this backtick with this, replace all, and then okay. So next we have to also count the number of ones in numbers starting with numbers ones in numbers starting with digit dg and of ones in n-digit number starting digit d and of which there is self count and minus, well, if it's that digit number then that's minus, it have what, 7 digits, so 10 to i.e. we just throw out the first digit and solve recursively. Finally, since we ignored n-digit numbers starting with 1, more precisely, we did not count their ones. If we do not count the first one, to count the thrown out ones, we simply add 10 to n minus 1, i.e. the numbers I cannot even explain this, since d over 1 therefore we count all numbers from 1 count all n-digit numbers from 2 99 blah 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 999. We count ones in all n-digit. Okay. In the second case, where the first digit of is 1, we have a similar case. First we count ones in n minus 1 digit numbers, of which there is then we count ones in numbers in numbers in n-digit numbers n excluding the first one, which we can do with the same recursion call as above. Finally, to count the number of excluded once we count the numbers, we count the n minus, we count n minus 1 digit numbers from to n minus 10 to something. I know this distinct explanation, but if you write down all cases, it will make sense. Time complexity is whew. So if we first, that's hard coded, and then I guess 01. So that's like log n. O1 work for each of the, I mean technically we are doing this, but we can also pre-calculate those. So let's pretend it's nothing. For each of the n digits of the origin of n, we can pre-calculate n minus 1 for all suitable n like under 10. And memory is 01, I think. I mean, it's not, but we could do this non-recursively, I think. It's not 01 because we are using a call stack. Log n, since we use recursion with a single int parameter, and depth O log n. Therefore the call stack takes up O log n memory. Okay. I puke from these kinds of questions, even though the solution is extremely good looking. Let's look at the editorial. Brute force. Okay, no one asked for that. Are you kidding? What is that? Ridiculous. 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 Holy shit. Okay, good one. Good one. Solution from deleted user. Oh, that's disgusting. Okay. How do I sort by most votes? 4 fucking lines. You kidding, my brother? I mean, recursively, maybe I would have a few lines too if I would use integers, but I don't think I could be bothered. AC short Java sol. What the freak? Why is there r plus 8 divided by 10 times k r? Okay, that's enough for today. Goodbye.